Hello everyone. So today is going to be our day 15 of the DAC challenge. And the question that we're going to solve today is a majority element that is greater than n by 2 times, right? So this is the question on Leetcode. It's an easy question though, but as you can see that it is asked in Amazon 9 times, Microsoft, Adobe, Apple, Google, and so on, right? Um, Almost as in all the fan interviews. But let me tell you, though it is written easy, but the question is fairly not that easy, right? There is a very important algorithm behind it that you need to understand, right? I cannot think of any other use case as of now, but I'll let you know in future if I know, if with this such algorithm, if any other question can be solved as well. Yeah. Here the question is given an array of size n, return the majority elements. Now, what is the majority elements that appears more than n by 2 times? You may assume that the majority element always exists in the array, right? So okay, let's just copy one example here, right? Okay, great. So this is the example, and what is the n here? N is like a no problem. We'll just simply find it out. Um, I got it. Why is it not zoomed in? Give me 1 second. I know this is annoying, but yeah, okay. So n is the 1, 2, 3, 4, 5, 6, 7, right? So 7. What is n by 2 then? If you have guessed it already, we always take the floor of it, so it's 3, right? So if an element, right, if any element in this array exists more than 3 times, so if it exists 4 or more times, it is called a majority element, right? For example, here, as you can see, 2 is 1, 2, 3, and 4. 2 is present 4 times, but 1 is present 3 times as well. Is 3 greater than 3? You will say no, right? It is not greater than 3. Here, you don't have to check the equal to, you just have to check the greater than value. So 2 will be the majority element, right? So let's start with the brute force, okay? Let's start with the brute. Let me copy it here, right? This is the brute force. Great. So let's do one thing, right? Let's start a loop which starts from 0 and goes till n minus 1, right? Great. Let's start a J loop as well, which starts from where? Now see, you need to initialize one counter, right? Let count maybe not here, maybe here. Like count is equal to 1, right? Because the array that the element that you're on to right now is at least occurring 1 times. So that's why we initialize it with 1. What you can do is you can initialize with 0 and then you can probably implement it. I'm really sorry. Yeah, I'll take that later on. But yeah, so this will go till I n, which start fairly with I plus 1, and this should go till n, right? And then you will, if you will say that, hey, if my array of I is equals to array of j, then fairly count plus plus. As soon as your j loop ends, so if this is your j loops, um, you know, a frame, then what you can do is, let me silence my phone. Sorry. Yeah, you have done your j loop part, and this is your I loops. Great. So if you check here that if my count is greater than n, or you can say array dot length, you can return the element, return maybe array of I, right? Else, when the I loop breaks, you can just simply return minus one, right? I mean, since you will notice that in this question there is you may assume that the majority element always exists. So here, right, your element will be returned. Any of the element will be returned, but again, we need to return something at the end of the day, right? We need to return, as you can see, the return type is a number. So, right, even if the for loop breaks or doesn't run for some matter, you will have to return something. So, we are returning -1, right? It doesn't really matter. It won't reach this place ever, as it is given in the question only, right? What's the time complexity, right? We'll be here, right? And then we'll check for here. We'll be here, then we'll check for every other place. Great. We'll be here, then we'll check all the other places. We'll be here, then we'll check all the places. You will say that why are we not starting our J loop from from zero only, because you are potentially missing on these many values. But don't you understand? Um, or shall we? Okay, let me think of a base case. This is too great. Uh, no, we'll have to start with I plus one only. Doesn't really matter. You will still count all these things. So drive complexity, fairly simple. We are running two loops, so obviously it's for n square, right? And space complexity is nothing because we did not use any extra space, so it's constant, right? Now the interviewer won't be happy, obviously, because you are using n square, and as you can see here, n is given as 5 into 10 to the power 4, which will be obviously give you a TL. Okay? Let's move on to a better solution. Now, when we are finding frequencies, right? Whenever we are finding frequencies, right? You always know that we use something called a map, maybe an object, maybe in JavaScript particularly. We note down what's the frequency, how many times it occurs, right? Great. So we'll have one object, right, which will be initialized empty as of now, and then we'll traverse the whole two, right? Two is two present in the object, you will say no. So mark it as with one. This is the key, this is the value. Again, two comes, you will say, hey, just increase yourself. One comes, does one exist? So you will say no. One. Again, one comes, sorry, sorry, you will increase it. Again, one comes, you will say, hey, increase yourself. Two comes, does two exist? Yes. So you will increase it. Again, two comes, you will say, hey, increase yourself. Now your object looks something like this. Two is four and one is three. In the value is three. You will again traverse and you will find that, hey, if a value is greater than length by 2, then you will simply return that value. How many, what is the time complexity for it? Fairly simple again. You will say that, hey, the value is, sorry, O of n for traversing the whole array plus a fairly O of, maybe not n, but we'll still say O of n only. Let's search in front of you. What is the time complexity of traversing in uh, in an object in Java script, right? Yeah, it's O of n, right? It's O of n. Okay. So let's assume that the length of the what do you call the object is also let's just assume it's O of m, because let's just say the value is m, right? So this is the time complexity, and space complexity. Again, you are using one extra space, so you will have an O of n. Again, that interview will tell you, hey, I don't want you to use an extra space complexity. Now you will move on to a to sorry, uh, where is it here? You move to optimal. Great. Now optimal. How will you do that? Copy it. Let's just copy it and paste it again. Okay. Let's first understand. Let's first understand the algorithm, right? I'll try run it in front of you. Then later on we can write the code. The code is fairly easy, so you don't need to understand any bit of it. You will know the intuition of it already. But it's a very important algorithm because you don't have to mug it up. You don't have to mug it up. But in questions like these where you have to count the frequency and in a 1D array, you can use such algorithm. And this algorithm is called, let me write it here. It's called Moore's voting algorithm. Now, as the word suggests, voting, you are counting the votes. You are counting the votes, right? How many times that particular index or that particular element is occurring, right? You are counting that. Great. Okay, let's start it. Let me do one thing. Let me increase it a little so that I can at least write something. Great. Let me use this. Sorry, use this, and I can use probably green. Yeah, great. I am here, right? I am here. So element becomes 2 and count becomes 1. No problem. Great. I'm assuming. Now, what is my approach here? I will assume that every time I encounter an element which has a count greater than 1, sorry, greater than 0, hear me out. Any element, I will assume it as my majority element if its count is more than 0, right? Here, the count is 1. I've initialized it with 1. So I'll assume that 2 is my majority element throughout the array. No problem. Great. You will see what we do, right? You will see. Now 2, right? I move here now. Is 2 here? Yes. So I'll increase the count. Great. Now next element 1. Not my The count will not be increased. Rather, it will be decreased. Why? Because it is not element. This is not equal to the element. Again, this is 1, right? I'll increase it and decrease it to 0. Now you will notice that my count has become 0. Now, till here, right? Part, if I take this part, what is the sub array's length? It's 4, right? Now in 4, 2 exists, sorry, 2 exists 2 times, 1 exists 1 time, or you can say other element, right? 2 exists 2 times. Now what is the division of it? It is n by 2, which is equal to 2, and it should be greater than 2. This value should be greater than 2. Basically, it should be 3 or more, right? But it is not. So in this array, I can assume there is no the the element here, 2, is not is not the majority element. Great. I'll move it here. Now my pointer is pointing to here. I'll say is my count equal to 0? Yes. I will remove this. I will assume 1 is my element now. 1 is my um, majority element. Great. So this becomes 1. Right? Next is 2. 0, right? Because 2 is not equal to 1. Great. Nice. What did we do when we encountered here? So what you have to assume is till here, this sub array here, 1 exists 1 time and other elements exist 1 time. And what is the length? Length is 2, basically. So you will say that, hey, no, this is not my majority element because in the length of 2, 1 exists only 1. Great. Now it becomes 0. So when we are at this position, this becomes our element. Sorry, this becomes an element and our count becomes 1. Great. Here it goes up. Now in this sub array, 2 is my majority element. 2 is my majority element because 1 is the length and 1 divided by 2 is nothing but 0. It should be greater than 0. Then the count should be greater than 0 and here it is 1. So 1 is greater than 0, right? Great. So I'll assume that 2 that 2 is my potential majority element. Notice the term, notice the term potential. Notice the term potential. You need to figure out that this is a potential majority element. This I am not stating that this is a majority element. I'm saying that it might be my potential element. Okay. Now let's read the question again. Now let's read the question. You may assume that the majority element always exists in the array. Now, you will notice that 2 is the majority element. 2 is the majority element because it occurs 4 times. If in the question it is given that you may assume that majority element always exists, that means this array contains two. The element that is my current element is my majority element. It is my element is majority element is majority. But if it is given, it wasn't given. This line wasn't present. You would have what you have done is you would have pasted this here again. You would have traversed it. You would have traversed the whole array here, 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 and you would have checked that if count of element is greater than n by 2, then you would have returned. Then you would have said, "Ki, हाँ, it is there," else you would have returned -1. Else element is element greater than n by 2? Question mark. This is the ternary. This is the ternary statement that if it exists more than n by 2 times, yes, you can say that, hey, the element is my answer, else my answer is -1. So I hope you got my point that hey, if it says that yes, it you may assume always that the majority element exists, then you can simply return the element that you have here, that you have here, right? That you have here. Else you will check. Else you will check that hey, is it even my is my count even more than n by 2, or I'm just assuming because I have written here that this is my potential majority element. This is my potential majority element. And why will it work? Why will it work? You need to understand. We we kind of divided our array, the input array, into smaller sub array, right? Into smaller sub array. We figured out, we figured out that majority element, if majority element always exists, then in one of the sub arrays, it should be a majority element. It should be a majority element. Now, why is it so? Because majority element, let's just say the sub arrays, they will not be always equal to the same length. Because here you will see there's a four length, there's a two length, there's a one length. They're not equal, the lengths are not equal. But if the majority element exists, then it should be cancelled. It should be cancelled by other elements. It should be more than something. It should be more than it should be present more than the other element, right? This is our intuition. This is our that in one of the subarrays, it should be a majority element. And here you can see that in the last subarray, you can assume that hey, yes, it is my majority. Great. I hope you understood. Let's try to write the code because code will be fairly simple. And let's kind of understand what is the time complexity. We are just traversing this whole array once. So O of n, had it be given that you may not assume that majority element always exists, you would check again. You would check again that hey, if the count is greater than n by 2 or no, right? So this will be my basically my time complexity. But now here it is given that you may assume it, so I will remove it. So this becomes my time complexity, and space complexity is obviously easy because we are not using any extra space, so it's constant every time. Great. Let's try to write the code. Let's say that hey, let count is equal to 0. I'm initializing it with 0. No problem. I'll say that element, you just don't be anything. You just don't be anything. I'll give you a value, don't worry. I'll start my loop. I should be less than nums dot then I must be. Great. Hmm. I'll say that hey, if my count is equal to 0, then what? Then what? I told you that your element will now change. You will assume another, you will assume this particular element. This is not num, this is num. You will assume that this element is nothing but the current element that you're onto and your count becomes 1. Great. Else if your array, sorry, the nums of I is equal to element. Now, if you have an element already, if you have an already, you will say that, hey, just simply do count plus plus. No problem. Yes. Else, you will say that, hey, count minus minus. Right. And now that is it is given that you may always assume that there's gonna be a majority element always in the array, you can simply return element. Right? Let's try to run this code. Great. It is accepted. Let's try to submit. Great. Excellent. Here, the follow-up question is, can you solve the problem in linear time in O of one space? Yes, we are doing that. Yes, we are doing that. Let's write a code. A comment here. Have had it been given that majority element may or may not exist, you could have, you should have run a new loop and check if the element, the count of element is greater than math dot load n by 2, right? Great. This is accepted. Let's try to write some code. Let's write some notes here. You need to use Moore's voting algo, where you will simply assume every element to be a majority element. If the count is equal to 0, then the next element becomes your potential majority element, else count plus 2. If the element current potential m- majority element is not equal to area by count minus 1. If it is given in the question that majority L may not exist, then run a loop again to check if the element count is great. Let's try to save it, remove it. Let's mark it as done. I hope you have understood today that we have completed by day 15. So we have completed half of our challenge. We are 50% done and 50% more is left. So thank you so much for joining in. I'll see you tomorrow with this question called majority element n by 3 times. Thank you so much. Bye bye.